Nuclear energy, power, promise, and problems. Imagine a single grain of fuel producing enough energy to power an entire city. Sounds unbelievable, right? This is the power of nuclear energy. But with great power comes great responsibility and serious risks. Today, let's explore nuclear energy, how it works, where it is used, its advantages, and its disadvantages. What is nuclear energy? Nuclear energy is the energy released from the nucleus of an atom. It is mainly produced through a process called nuclear fission, where atoms of uranium or plutonium are split. When these atoms split, they release a huge amount of heat energy. This heat is used to boil water, produce steam, rotate turbines, and generate electricity, similar to how coal power plants work, but with a different fuel. Where is nuclear energy used? Electricity generation. Electricity generation is the most widespread and important use of nuclear energy. In nuclear power plants, energy is produced through nuclear fission, where atoms of uranium or plutonium are split in a controlled manner. This process releases a large amount of heat, which is used to convert water into steam. The steam then spins turbines connected to generators, producing electricity. Nuclear power plants are capable of supplying continuous and reliable electricity to millions of homes, industries, hospitals, and entire cities, making them a vital part of a country's energy infrastructure. Medical field. In the medical field, nuclear energy plays a crucial role in diagnosis and treatment. It is widely used in radiotherapy to treat cancer, where controlled radiation helps destroy cancerous cells without harming surrounding healthy tissue. Nuclear techniques are also used in medical imaging, such as PT scans and nuclear medicine tests, which help doctors accurately diagnose diseases and monitor organ function. Additionally, radiation is used to sterilize medical equipment, ensuring that surgical tools and supplies are free from harmful microorganisms, thereby improving patient safety. Industry. In industry, radiation is widely used for quality control and material testing. Non-destructive testing techniques use radiation to detect internal cracks, defects, or flaws in metals, welds, and machinery without damaging them. This ensures safety and reliability in industries such as construction, aerospace, and manufacturing. Radiation is also used to measure thickness and density of materials like paper, plastic, metal sheets, and liquids during production. These measurements help maintain uniform quality and reduce material waste. Additionally, radiation is applied in sterilizing industrial equipment and improving material properties, such as strengthening polymers. Overall, radiation enhances efficiency, accuracy, and safety in industrial processes. Space and research. Nuclear energy plays an important role in space exploration and scientific research. In space missions, it is used as a reliable power source for satellites, space probes, and spacecraft, especially in deep space where solar energy is limited. Nuclear-powered systems provide long-lasting energy, allowing missions to operate for many years. In research, nuclear technology supports scientific experiments, medical research, and the development of advanced technologies. It is also used in studying materials, generating isotopes, and understanding fundamental physical processes. Overall, nuclear energy enables long-term space missions and drives innovation and progress in scientific research. Advantages of nuclear energy. Massive energy production. One of the greatest advantages of nuclear power is its ability to produce massive amounts of energy from a very small quantity of fuel. Nuclear reactions release energy by splitting atoms, which generates far more power than burning fossil fuels like coal, oil, or natural gas. A small amount of nuclear fuel can supply electricity to large cities for long periods, making it highly efficient. This high energy density reduces the need for large fuel storage and frequent transportation, lowering overall resource consumption. As a result, nuclear power plants can operate continuously and reliably, providing stable electricity to meet growing energy demands. This efficiency makes nuclear energy a powerful option for large-scale power generation. Low carbon emissions. Nuclear power is considered a low-carbon energy source because it produces very little greenhouse gas emissions during electricity generation. Unlike coal, oil, or gas power plants, nuclear reactors do not burn fuel, so they release almost no carbon dioxide into the atmosphere while operating. This helps reduce air pollution and slows down climate change. Although some emissions occur during fuel mining and plant construction, they are significantly lower compared to fossil fuels. Because of this, nuclear energy plays an important role in providing large amounts of electricity while supporting global efforts to cut carbon emissions and protect the environment. Reliable and continuous power. Nuclear power provides a steady and dependable supply of electricity at all times. Unlike renewable sources such as solar and wind, which rely on sunlight and weather conditions, nuclear power plants operate continuously day and night. They are designed to run for long periods without shutdowns, delivering consistent energy output. This makes nuclear power especially important for meeting constant electricity demands and ensuring grid stability. Its ability to generate power without interruption makes it a reliable backbone of modern energy systems. Disadvantages of nuclear energy. Risk of accidents. One major disadvantage of nuclear energy is the risk of accidents. Nuclear accidents like Chernobyl and Fukushima have shown that failures in nuclear power plants can lead to serious long-term environmental and health problems. Radioactive materials released during such accidents can contaminate air, water, and soil, making large areas unsafe for living or farming. Exposure to radiation can cause severe health issues, including cancer, and may affect future generations. Although modern safety systems have improved, the possibility of accidents still raises concerns about the overall safety of nuclear power. Radioactive waste. Radioactive waste is one of the biggest challenges of nuclear energy. The waste produced from nuclear power plants is extremely dangerous and remains radioactive for thousands of years. If not handled properly, it can harm humans, animals, and the environment. Safe storage and disposal require advanced technology, strict safety measures, and secure locations to prevent leaks or contamination. Managing nuclear waste is costly and complicated, and many countries still struggle to find permanent disposal solutions. Because of its long-lasting nature, radioactive waste continues to raise serious concerns about the long-term safety of nuclear power. Security threats. Security threats are a serious concern with nuclear energy. Nuclear materials can be misused for making weapons or used in terrorist activities if they are not properly protected. Unauthorized access, theft, or poor security can lead to dangerous consequences that threaten national and global safety. Because nuclear materials are highly sensitive, strict security systems, monitoring, and international regulations are required to prevent misuse. Ensuring the safe handling, transport, and storage of nuclear materials is essential. These security risks make nuclear energy a subject of concern despite its benefits. Is nuclear energy safe? Modern nuclear plants are designed with multiple safety systems and strict international regulations. When managed responsibly, nuclear energy can be safe, but even small mistakes can lead to major consequences. Conclusion. Nuclear energy is a powerful tool that can light up cities and save lives, but it must be handled with extreme care. It is neither completely good nor completely bad. Its impact depends on how wisely humans use it.